Medical researchers in Queensland say they've taken a big step forward in the fight against superbugs caused by antibiotic-resistant bacteria. They've worked out how the bacteria share antibiotic-resistant genes. Professor Mark Schembri from the University of Queensland is one of the researchers of the study, which has just been published in the journal Nature. Mark joins us now. Hi there. So can you tell us more about what you've discovered?
Yeah, hi, Roz. Look, I guess with respect to your viewers, I'm sure that everyone would be familiar with the situation where they have an infection, they go to their doctor, they get an antibiotic, and that antibiotic doesn't work and it doesn't clear the infection. They go back to their doctor, they get a different antibiotic, and if they're lucky, that second antibiotic would work. Well, our research has uncovered the mechanisms by which bacteria actually spread antibiotic resistance genes. So we actually identified genes that produce a syringe-like structure that connects bacterial cells together and through which antibiotic resistance genes pass through. We also identified a protein that controls this process. We identified its structure, so its three-dimensional configuration, and we determined how it interacts with its target.
So how big a breakthrough, Mark, is this in the fight against superbugs, in your opinion? Modesty aside.
So the fight against antibiotic resistance is being taken on many different fronts, and this is just part of the picture here to try and understand the transfer of genes. One of the real problems we have is in environments like hospitals and healthcare facilities where resistance genes spread very quickly. Now we have an idea of the fundamental process that occurs. We have an idea of how this is controlled, and so hopefully we can start to think about ways that we can reduce the spread of these genes.
So the next stage of your research then, Mark, is to work out how to stop the process of resistance being passed on?
Yeah, I guess really our work has uncovered a target, and that target is now a target that could be inhibited. And so the next step would be to try and develop molecules that could inhibit that process.
So what would it mean for current antibiotics? Would they become more effective against bacteria, or would new antibiotics still need to be invented or discovered, if you like?
Well, again, this is a complicated picture, and we need both. We need new antibiotics because of the resistance and the rapid rate that it develops. But at the same time, if we can slow down resistance, so if we can slow down the movement of genes between bacteria, and actually slow down and reduce the spread of these resistance genes, then we may be able to rescue some of the current antibiotics that we have at our disposal. So we need to really tackle this on both fronts.
Yeah, and superbugs, they are still a massive problem in our hospitals, of course, aren't they? Especially with COVID-19 around as well.
Yeah, absolutely. Look, it's predicted around the world that there are around 700,000 deaths every year that occur due to infections caused by superbugs that are resistant to multiple different antibiotics. And it's also predicted that if we do nothing with respect to antibiotic resistance, then that number will increase to around 10 million by 2050.
Wow. OK, congratulations on your success, Professor Mark Schembri, and thank you for talking to us today.
Thanks a lot, Ross.
Australia's best pie competition is going ahead this year despite the pandemic.